The next concept we're going to talk about is mean value theorem. The image helps a little bit, basically the statement underneath it. So I want you to process it. We might have to read it a couple times. It says, if f is a continuous function on a closed interval a to b and differentiable on the open interval from a to b, then there exists a number c in the interval from a to b such that the first derivative of c, which is just the slope of the tangent line at that point, is equal to f of b minus f of a over b minus a. So basically the slope of this secant line is going to be equal to the slope of the tangent line at the point C. So what we're going to establish that relationship there. Here, the equivalent of that, what did they do here to just get the equivalent? Yeah, cross multiplied right there. So this is like a working form a lot of times. So the image will just try to help you pull together what we're going to do next. Okay, so we're going to find a value c. So what we're going to be looking for is we're going to be looking for this value c right here. Okay, keep in mind, find a value c such that the conclusion of the mean value theorem is satisfied for the given function on the given interval. Okay. Okay, so the first thing we're going to do is we label our a and b and our interval, and then we write our mean value theorem relationship down here. So we want to evaluate that. So the first thing we're going to do is evaluate f at a. So here, f of a is just if our a is -2, evaluate the function at -2. So in your original function, everywhere there's an x, you're going to plug in a -2. That's the case, you'll get +2. And the next thing you're going to do, just getting all of our work, is evaluate the function at b, f of b. Well, f of b, if this is our b term, at the other endpoint is 2. So f of 2, plug that in, careful with your signs. I get the value of -6. Okay, once we know f of a and f of b, we can then plug that into this formula right here, into this equation. So f of b, we got to be -6. F of a, we got to be 2, and then b was just 2, and a was -2. So we insert all our values in and simplify to get our right-hand side is equal to -2. So the right-hand side of this is just simplifies to -2. All right, the next thing we want to do is evaluate f prime of c. Well, the first thing we got to do is find the first derivative anyway. What is the first derivative of our given function? Just -6x squared plus 6, right? Okay. What does it mean when I tell you to take the first derivative of c? Everywhere there's an x, you plug in a c. Right, good. So f prime of c is just going to be simply -6c squared plus 6. Okay. Then we're going to go ahead and take this, plug in our value we have for f prime of c and set it equal to -2 and solve. So here, let's just look at the algebra. So this right here is our f prime of c equal to -2. We're solving for c. Remember, we're looking for the point c, which holds which the mean value theorem holds true. So algebraically, you solve, you're going to get the c square root of c on each side. So we get plus or minus 2 over the square root of 3. This is going to be the value of c that satisfies that relationship. All right, we're going to do the same thing for the next function. F of x is equal to just x squared, a basic parabola, and where it's continuous and differentiable on the interval from -2 to 1. So before we start, we're going to write down our f prime of c and our relationship there, our mean value theorem relationship. And then we're going to go right into evaluating. So evaluate f of a. What is a? -2. Evaluate f of b. What is b? 1. So take a few minutes to go ahead and evaluate that, and then you can look back at this and check your answer. Pretty basic algebra here, so it shouldn't take you but a minute. Then our next step is to plug it back into our right-hand side to simplify and get our value for f of b minus f of a over b minus a, which in this case, if I plug in f of b is 1 minus f of a is 4 over b, which is 1. Here's your original a and your original b. We should simplify to get -1. So the right-hand side of this just simplifies to be -1. Our next step is we're going to evaluate the first derivative to start. Then we're going to evaluate the first derivative at c, and then take our answer for that and set it equal to -1 to find the value for c that satisfies the mean value theorem. Okay, so our first derivative of x squared is just 2x. F prime of c is just 2c. So when we set 2c equal to -1, this is our 2c is equal to -1. Divide both sides by 2, divide both sides by 2, and we just find out that c is equal to -1/2. Okay, the next concept we're going to look at is Rolle's theorem. And let's see if this image helps us put together this statement underneath. So if f is continuous on a closed interval and differentiable on the open interval, if f evaluated at a, that's this point here, is equal to f evaluated at b, this point here, meaning they're exactly the same, then the first derivative at c is equal to 0. For at least one number c in the interval a to b. Okay? So we're gonna work with this here. And the first thing you're gonna do is if we start with our function f of x equals x squared minus 2x from 0 to 2, we want to find the value for c that satisfies Rolle's theorem. Okay, similarly like we did just a minute ago, we're going to take our, find our f evaluated at a. What is a in this case? 0. What is b? 2. So f of a, real simple substitution there, we just get 0. F of b, in this case, you just get 0. Okay. The conclusion here is we say if f of 0, which is our f of a, is equal to the f of 2, that means f of a is equal to f of b. If that's the case, then we can take our first derivative. What's the first derivative of x? 2x minus 2, and we set that equal to 0. Okay, so we have this whole side. So I take this first derivative, set it equal to 0. My first derivative is just going to be 2x minus 2. Set that equal to 0. And then evaluate that first derivative at f prime of c. So the first derivative at c. Everywhere there's an x, put a c. 2c minus 2 equals 0. Solve both sides for c. We find out at the c equals 1 value, you'll have the relationship here.